Hello everyone. Today we have another experiment whose objective is study of hydel pumped storage system. So, what is introduction to pumped storage hydropower? It is a type of hydroelectric energy storage. It is a configuration of two water reservoirs at different elevations. That means different heights. So that can generate power as the water moves down from one to another, which is also known as discharge and passing through the turbine. The system also requires power as it pumps water back into the upper reservoir. It acts similarly to the giant battery because it can store power and then release it when needed. So pump hydro storage has offered a cost-effective way to provide a reliable, large-scale balancing and grid services. New pumped hydro storage technologies such as variable speed capability give plant owners even more flexibility by providing grid frequency support in both the directions, in turbine mode as well as in pump mode, as well as the quicker response times. So high inertia of rotating machines can also stabilize the grid in case of disturbances, which can also influence the grid frequency. It can also enable low inertia renewable energy such as wind and solar to enter the grid and allowing their power to be transmitted over great distances. So hydro storage technology is an enabler for the transition and modernization of the 21st century power generation. It provides production, storage and grid stabilization. It stores energy using a system of two interconnected reservoirs, and we have already discussed. So with fixed speed pump storage plant, power regulation is possible while the plant is generating electricity, but with state-of-art variable speed technology, power regulation in specific range is possible while generating and pumping, providing additional flexibility to support the grid stability. Now you can see from the figure there is open loop pumped storage hydropower plant and there is closed loop power generation, right? So what are the benefits? First benefit is it is large scale. So this is the attribute that adds that is the best position pumped hydro storage, which is especially suited for long discharge durations for daily or even weekly energy storage application. It is cost effective. It is more reactive. The growing share of intermittent resources reduces the inertia of the grid, which increases the stability. Also, it is a key to avoid incidents, and hydropower production and storage can provide inertia and load balancing services to the grid. So current technology and it also provides response times that are counted in seconds. Next, mature technology. Now, for decades, pumped hydro storage has offered a cost-effective way to provide large-scale balancing and grid services with predictable cost and performance. Now, new hydro storage technologies such as variable speed now give the owners more flexibility, more reliability, more availability, more efficiency, and more output. So, renewable and sustainable hydropower, it uses forces of water that can be pumped uphill and turbined downhill as much as needed. Pumped hydro storage plants have lifetime of more than 40 years. It is multifunctional. We can use it for irrigation. We can use it for water distribution. We can also manage our waste water management. So you can see from the configuration, this is a configuration scheme for the pumped hydro storage plant and renewables. We can see this scheme, the conventional pumped hydro storage plant, then we have connected variable renewable energy sources also. So you can see from the figure there are different configurations. First one is conventional, that means which was already being used in earlier times, like it was the conventional type of the system. This type of the system guarantees rapid startups and adjustable power output depending on the demand. It also output absorbs the surplus variable renewable energy generation in the system, minimizing the losses. Coupled schemes means both combined pumped hydro storage plant plus variable renewable energy sources. So VRE with the pumped hydro storage plant as storage on site. In this system, a wind or solar plant would be installed in proximity to a pumped hydro storage plant, right? When we talk about variable renewable energy sources, we have either a solar plant or we have wind plant, which is installed in proximity. So VRE technology integrated to PHS facilities, floating PV systems can be installed in the upper and lower reservoirs, creating a hybrid model that can take advantage of existing high voltage grid connections. So schemes with the floating PV, where PV panels are installed on the water rather than on the lands, it increases the efficiency, it reduces the evaporation losses, it increases the solar cell efficiency, and also taking advantage of existing transmission infrastructure and readily combining with storage capabilities to provide dispatchable, uninterruptible, and flexible power generation. So these are the services provided. Load shifting, we can go for load shifting, we can go for frequency regulation, we can go for fast and flexible ramping, we can go for capacity firming, black start. So key factors to synthesize innovative ways. First is the increasing digital operation of pumped hydro storage, investing in public-private projects, then establishing a regulatory frameworks, then leveraging existing infrastructure by retrofitting already existing pumped hydro storage facilities. So what are the implementations required in when we talk about technical requirements? Facilities that fulfill the grid connection requirements. For coupled scheme, we need floating solar PV plants and also wind power plants, right? For when you talk about solar software, optimization software for the hybrid systems, or including PHS and VRE, that is a variable renewable energy source, and batteries. Advanced weather forecasting tools are required. Automation of various processes is required. Then we talk about policies. Various policies has to be, reframed for this type of systems when we are moving from conventional to VRE plus PHS. So we have to take care of that also. When we talk about regulatory requirements, incentives, we have to modify the incentives. We have to increase our time granularity in electricity markets, also ancillary service. We have to take care about the grid codes also, system operators, generators, etc. So this was all about the pumped storage plant, hydro plant. If you have any doubts, you can contact me. Thank you so much.